Welcome to the unit on equations and inequalities, simultaneous linear equations. The objectives for this session are to solve simultaneous linear equations using elimination and using substitution. Linear simultaneous equations in two unknowns can have exactly one set of values that will make a pair of equations true at the same time. Let's take a look at an example. The solution to the following pair of equations, which is shown on your screen, is x equals 1 and y equals 3. Let's check this by substituting the x value and the y value in one of the equations. So let's check. 3, the coefficient of x, 1, x equals 1, 2, the coefficient of y, and y equals 3. Does indeed equal 9. 3 times 1 plus 2 times 3 equals 9. So the left-hand side equals 9 and the right-hand side equals 9. We can also check in equation 2. X equals 1, 4 from the equation, y equals 3, does indeed equal minus 11. So the left-hand side equals minus 11, 1 minus 4 times 3. And of course the right-hand side equals minus 11 too. And therefore we've checked that x equals 1 and y equals 3 do indeed satisfy both equations. Let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at example 2a. Find the point of intersection of the following using elimination. Y equals 2x plus 3 and 5y equals x plus 24. So what are the steps required to solve this? First, make the coefficients of x or y the same. Next, subtract the equations to eliminate x or y. Third, find the uneliminated variable. And finally, substitute into one of the original equations to find the eliminated variable. We will now proceed to solve example 2a. We must either make the coefficients of x the same or the coefficients of y the same. We will proceed to make the coefficients of x the same. Multiply equation 2 by 2 to give 10y equals 2x plus 48. So 2 times 5y is 10y, 2 times x is 2x, and 2 times 24 is 48. Now subtract equation 1 from equation 2' to give 9y equals 0 times x plus 45. 10y minus y equals 9y. 2x minus 2x equals 0x. And 48 minus 3 equals 45. So dividing both sides by 9 gives y equals 5. Now substitute y equals 5 in equation 1 to give 5 equals 2x plus 3. Rearranging gives you 2x equals 2. And finally dividing by 2 gives x equals 1. Now check that y equals 5 and x equals 1 is correct when substituted into equation 2. Substitute y equals 5 and x equals 1 in equation 2. Now the left-hand side equals 25 and the right-hand side equals 25. So the left-hand side and the right-hand sides are equal. Therefore, the check confirms that y equals 5 and x equals 1. We will now proceed to solve example 2b. We must either make the coefficients of y the same or make the coefficients of x the same. We will proceed to make the coefficients of y the same. Multiply equation 1 by 3 to give 3y equals 9x minus 12. Now subtract equation 2 from equation 1 dash. Three y minus 3y equals 0y, 9x minus 2x equals 7x, and minus 12 minus minus 19 is plus 7. Next, find the uneliminated variable. So rearranging gives that 7x equals minus 7, and dividing both sides by 7 gives x equals minus 1. Now substitute into one of the original equations to find the eliminated variable. So substituting x equals minus 1 in equation 1 gives that y equals 3 times minus 1, the value of x, minus 4 equals minus 7. So we have the two values now. X equals minus 1 and y equals minus 7. Finally, check that the values of x and y are correct in the other equation. So let's substitute these values in equation 2. So substituting x equals minus 1 and y equals minus 7 in the equation gives 3 times minus 7 equals 2 times minus 1 minus 19. Indeed, both sides are therefore equal. Left-hand side equals right-hand side equals minus 21. Now for example 3. Pause the video and have a go. Press play when you're ready to view the solutions. So what are we required to do to solve these two equations by using substitution? Let's go through the steps. First, rearrange one equation so that one unknown is the subject of the equation. Next, substitute in the second equation. And finally, check by substituting the x and y values in the equations. So let's solve this example. We are going to make y the subject of the equation. So let's rearrange. First we're going to make y positive, so we add y to both sides. Next we subtract 3 so that y is isolated on one side. And now we substitute equation 1 dash in equation 2 as shown. And then tidying up gives us 5x plus 6x minus 6 equals 16. Then rearranging and tidying up gives us 11x and 16 plus 6 is 22. Dividing through by 11 gives us x equals 2. Now we substitute x equals 2 in equation 1 dash. So y equals 3 times 2 minus 3. To give y equals 3. And therefore the solution is x equals 2, y equals 3. Let's now check that this is correct. So on the left-hand side, we have 3 times 2 minus 3. And of course, the right-hand side, we have 3 as well. So left-hand side equals 3, and right-hand side equals 3. And therefore, the two sides are equal. Now let's check in equation 2. 5 times 2 plus 2 times 3 equals 16. So the left-hand side equals 16 and the right-hand side equals 16. Therefore, x equals 2 and y equals 3 satisfy the given equations. So this brings us to the end of this session. If you have understood its contents, you should be able to solve simultaneous linear equations using elimination and using substitution. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.